My guest again today is Andy May.
I just wanted to discuss the firing of Dr. Marty Rowland for publishing the paper that Marcel Crok and I wrote together called Carbon Dioxide and a Warming Climate Are Not Problems. It was published in May 29th, 2024, and it's in the top 1% of all 29 million peer-reviewed papers followed on Wiley's altmetric website. Although the paper has only been out a little over a year, it's been cited 26 times according to Google Scholar. Dr. Roland calls this firing Orwellian, and I totally agree. It had nothing to do with anything he did. It was purely based on politics. The paper sparked a lot of debate, both in support of it and critical of it. It appears that, like I said, that Dr. Rowland was fired for political reasons and not based on any legitimate problem with our paper, which is a solid presentation of the facts about climate change and its possible dangers today. It contains no speculation about the future, no model results. We didn't do any models. We just presented the evidence as it exists today. Dr. Roland invited me to write the paper. He wanted me to explain the scientific basis for the denier or skeptical view on man-made climate change. It was incorporated into a special issue of the American Journal of Economics and Sociology that covered all views on climate change. The intent was to help the public assess the full range of views on the impact of man-made climate change, a very laudable goal. The paper presents our views, and it's both an opinion piece and a literature review paper. We avoided all speculation. It's based strictly on accepted peer-reviewed literature and observations. Wiley, the publishing company hired by AJES, encouraged the journal's board to retract the paper because they disagreed with the conclusions, but not because they identified any errors in the paper. And no errors in the paper have been brought up even since. I mean, it was very straightforward, very conservative in its presentation of the data. The board of the journal quite correctly denied the request, but did publish 3 papers critical of our paper in the same journal, the same issue of the journal, which is certainly their right. The arguments in the critical papers can be summarized as follows. Number 1, May and Crok are correct that there is no sign of any unusual global danger from man-made climate change today, but just wait. The climate models say there will be dangers in the future. Then number 2, I don't see any errors or flaws in May and Crok or in the references, but you must be wrong because the consensus of climate scientists say you are wrong. That's purely political and not scientific. When Dr. Roland inquired about why he was being fired for simply publishing the full range of views on the science of dangerous man-made climate change, he was told there was only one legitimate view of climate change, that it is dangerous. When Dr. Roland correctly pointed out that the climate establishment and the IPCC have not identified any current climate change dangers, he was told that the IPCC is withholding conclusive evidence of the dangers from the public, that they have secret data showing that it is dangerous. Dr. Roland asked why they are keeping such important data secret and received no answer at the time. Later, he found out that the board believed in the secrets because of an article written about James Hansen in a blog where Hansen is quoted as saying, quote, "The crisis is worse than we thought, but it's not too late to avert the very worst outcomes." This was stated by James Hansen as told to Media Tell the Truth, a blog, as I said. Pretty thin evidence. Besides his now terminated position of special editor for AJES, Dr. Roland is a lecturer at the Henry George School of Social Science, a New York City parks environmental engineer, and the chair of the Education Committee for the Board of Trustees for the Henry George School of Social Science. Losing his job is not a crisis for Dr. Rowland as much as it is a crisis for science and freedom of speech and the press. Science is never only one opinion. Science is never settled, and science dies when all views are not aired openly. Sunlight is the best disinfectant. Dr. Rowland's idea to publish all well-documented views on climate change in one issue is a good one. That is real science. Firing him for doing this is unscientific in the extreme and a crime against free expression everywhere. The original purpose of the AJES when it was created 83 years ago was to offer a periodic systematic synthesis of investigation of social issues, according to Dr. Rowland. This is exactly what he was trying to do, since modern climate science no longer has much to do with science. It's now a social and political issue. The fact that Dr. Rowland was fired for soliciting and publishing our well-referenced, straightforward, and plain language defense of the skeptical position on the dangers of climate change simply underscores that point. All the critics of our paper assume the consensus man-made climate change is dangerous hypothesis is correct and all opposing views are wrong. Yet May and Crok show there is no evidence that climate change is dangerous. Assuming that the consensus is correct and then demanding that we offer a viable alternative hypothesis before we can criticize them, as AJES editors Gwartney and Lowe did, is egregiously unscientific and political. Criticizing the consensus hypothesis is what scientists do. It is why we are here. Further, the UN Governmental Panel on Climate Change and other similar climate change organizations have pushed this hypothesis for over 30 years and have yet to convince the public there is a problem. 30 years is a long time to push a failing agenda, a clear signal that the consensus need to reevaluate their assumptions. So that's my summary of what happened and a little editorial comment.
So this feels like crazy stuff that's been kind of happening for decades, but maybe it's towards the end of it. I can't imagine it's going to keep happening. And do you have a sense that we're kind of at the end of this type of craziness?
I do. I do have that sense. I'm more optimistic now that things will get better than I have been in a long time. I've been studying this for over 20 years. And I've seen, I mean, I remember when ClimateGate happened in 2009, I thought, well, this is definitely the end. You know, I mean, no hypothesis can survive this. But of course it did. And in fact, it got worse. President Trump's speech to the UN was great. What he said was accurate. And we'll just have to see what they do in Europe and Australia. I see the focal point of the flawed hypothesis as lying mostly in Europe and Australia today. I think the US public is properly skeptical. And you don't really hear very much from the usual suspects on climate change anymore, at least in the US. So let's be hopeful that the US can lead the world out of this nonsense.
So you must have some juicy details that you can share about what really happened here and who really was behind the pushback against reality.
I have some suspicions, no evidence, but I think that Al Gore led a group of radical environmentalists in the 1990s, and he pushed them to push this. They saw it as possibly resulting in two things. One is they could make a whole lot of money out of government subsidies of quote unquote green energy. I'm not sure it's really all that green, but and then secondly, they saw this as an excuse to have a global government which is really what I think they wanted mostly. This was the way to present the public of the world, not just the U.S. public, with a problem that had to be dealt with globally, with all nations participating. They wanted probably something like a European Union, but a global union, and this was their excuse. I don't think a lot of them really cared much about climate change one way or another. They just saw it as a useful tool to getting what they wanted, which was a global government. And there's an awful lot of billionaires out there who want a global government. And I can see a lot of their reasoning. They have to deal with local regulations in 200 countries now to have a global business. And their businesses are global. The cost of regulatory compliance is huge. But if all the countries of the world were united and you could freely distribute goods back and forth, they could drive their costs way down. And so that was probably a motivation also. You notice that the Democratic Party and the liberal parties in Europe are the parties of business these days. They're the parties of big business and billionaires. That's where their money comes from. And so I think there were a lot of motivations for them to try and set up a global problem to be dealt with globally.
So how about the pushback, though, against this particular paper? That do you think Michael Mann, or do you have any names or any details of how this happened this time?
Well, Michael Mann was certainly involved. I mean, it was just a few days after the paper came out online that he was twittering about it like crazy, calling it a crock because of my co-author's name.
Good one.
And so, and then it was a couple of days after that some anonymous person on Twitter published. He goes by the name Bonus, or she. I don't know if it's he or a she. And Bonus was quoting Michael Mann profusely. I mean, all through his posts critical of our paper. So I dealt with that, and not long after that, on a website called PubPeer, which is supposed to be a way to criticize papers in a more official way. Again, we see somebody coming up criticizing our paper, and again citing Michael Mann profusely all the way through his post. So yeah, I think Michael Mann definitely had a lot to do with the criticism of our paper.
Do you have any comments, by the way, on him just resigning from some position at Penn?
Yeah, fantastic. But it's amazing that how many people are critical of Charlie Kirk. I mean, what did he do? And as far as I could tell, he was a big public figure, but he was a very nice person.
Yeah, he was not Hitler.
And it's related to the thing on Charlie Kirk. Huh?
Yes, it is.
I mean, it's just so I would say that him being forced to resign from a position is very much warranted here.
Absolutely.
There are links at the bottom of my presentation, which I'm sure you'll post. People can go there and see all the nitty-gritty details. I was a bit appalled by the whole situation over Tennis Pullis's critique, and so was Marcel Crok. He was upset about it. The critique was sent to me months before it was published, and for peer review. I peer reviewed it in some detail, pointed out a lot of grammatical errors, a lot of actual factual errors in the talk. Yet all the grammatical errors, I think maybe except one, and all the other mistakes in the paper were still in it when it was published. So, and I don't even know if my peer review was sent to Tennis Pullis or not. That Marcel kind of doubts it was, because he thinks that if Tennis had seen my critique, he would have made some changes, which is probably true. So the peer review definitely wasn't working in that particular case. And I don't trust peer review in climate science at all. Probably the only field where peer review is less effective is medicine and nutrition, but that's another issue we can get into. But the general idea of suppression of science and suppression of criticism and the censorship that's gone on is it bothered me. I was surprised to find out that Wiley, which publishes thousands of scientific journals, was actively involved in trying to get my paper retracted. It makes me wonder about other retractions of papers that seemed to be fine, and but they were still retracted just because of a comment or two in there. There was a famous retracted article by Alamonte in a Wiley journal that was retracted, but both Roger Pielke Jr. and I can't find anything wrong with the paper. It's fine. And the conclusions do draw from the data presented in the paper. So go ahead.
I'm working on getting Alamonte himself on this podcast to talk about that. It sounds like he might be ready soon to talk about that one.
Good. I want to see that podcast.
Yeah. Before I forget, I have changed your opening statement into PDF, and you, like you said, you have tons of links at the bottom. So people who really want to dig into it can go to that statement and click the links and find out everything about the pushback, et cetera, right?
Yeah, that's right. I documented every criticism I knew of and my response to it.
Yeah, I'd like to compliment you. You are so thorough. You're not phoning it in, as they say, that you really go the extra mile to document stuff, huh?
I try. Yeah, it's the devil's in the details, in my opinion. And there are so many arguments for and against climate change that just gloss over important details. I try and get into all of that. You know, exactly what do people mean, and exactly how does it compare to observations. I'm a big believer in observations, and I don't like models, even though I spent a 42-year career making models. I mean, I still don't like them. They're useful tools, but they don't give you an answer.
What sort of models did you work on? I'm curious.
Petrophysical models. I wrote them and used them to analyze petrophysical data. Petrophysics is just a fancy name for rock physics. What I did was I studied the physics of rocks and their strength and porosity and liquid contents like oil and gas and water.
Yeah, so those models can be useful, but modeling that is probably orders of magnitude easier than trying to model the entire global climate, right?
I think that's a fair statement. I had a pretty good environment. I mean, if you drill a well and you take physical measurements of the rocks, it's pretty controlled and it's a small volume. You've got a lot of control on your model. You can tell if it's right or wrong, how wrong it is. It's amenable to statistical analysis. Climate is, I mean, it's such an open thing. It's open to space at the top. It's open to the oceans at the bottom, which have an enormous heat capacity. There's clouds that come and go, and cloud cover changes constantly. So you have a different amount of radiation striking different parts of the Earth. The radiation that the Earth itself emits has so many avenues to get out that it's a very uncontrolled environment. And I laugh sometimes at the ways that climate scientists try and measure the error in their models. But basically, they're measuring error in their model by using a bunch of other models because they don't have any way of telling what reality is. Yeah, it's incredibly complicated. It's a huge issue, and the world is a very big place.
So from your perspective as a modeler and from a guy who's dug deeply into natural variation and stuff, how hopeless is it? in 50 years from now? How well can we model climate even then? Any ideas?
I don't think we have a clue. 50 years is a long time. I'm pretty happy with weather forecasting. I follow Dr. Ryan Maui's Substack page and so on. I mean, he really knows what he's doing. And we can go out 10 days and be reasonable, but even Ryan Maui can't tell anything beyond that. And then when you get a month out, I mean, it's just hopeless. So it's to try and see what the average weather is going to be like in 50 or 100 years, they're totally clueless.
I have a couple of questions about people who try to predict stuff maybe 6 months in advance. Or how about the Old Farmer's Almanac or whoever that is? Do you have any faith that they can predict what the winter is going to be like, or is that kind of a coin flip?
It depends. I looked into the Old Farmer's Almanac. It's got a long history, and they do a decent job in the continental United States, 6 months or a year in the future, in broad brush terms. So they use the sun mainly as their primary indicator, and the position in the solar cycle. But it's a very broad brush forecast. You know, they're not trying to tell you a year from now it's going to rain a lot. They're just saying that the general trend of precipitation over a huge area of the United States is going to trend higher than average or lower than average. So it's not a climate model in the sense that the IPCC says a climate model should be. It's a very, very, very broad brush thing based on solar cycles. And they do a decent job in that sense, but it's very general.
What do you think of Joe Bastardi's approach? It seems like he looks a lot at history of storms to try to predict what's going to happen next storm-wise.
I'm not very familiar with his work. I don't know.
Do you think it's extremely important volcanic activity in the Pacific underseas in order to produce maybe El Ninos or La Ninas? Have you looked into that much?
I don't have any confidence that volcanic activity has a large impact on El Nino and La Nina neutral, but it can certainly enhance the effect if it's a tropical eruption, depending on whether it's subsea or on the surface. It depends on the type of volcanic eruption. Unga Tonga, I think, definitely enhanced an El Nino cycle, for a few years. But the impacts of volcanism, I think, are misrepresented because the impacts really die out after a few years. So it's a very temporary phenomenon. And climate is a 30-year thing. El Nino and La Nina is a 7-year plus or minus type of thing. Its fundamental cycle appears to be related to solar cycles. So at least the La Nina and neutral part are driven by solar cycles. El Nino is a little more complicated, but it's probably just the oceans expelling excess heat. And the longer term El Nino record suggests that El Ninos are diminished when the world is warmer, and they're enhanced when the world is getting cooler. There were a lot of El Ninos before the Little Ice Age, as an example. And then we went into the Little Ice Age, we got down to the bottom of it, and there weren't so many. And then we started to come out of the Little Ice Age, and there were more El Ninos. Like in the 20th century, there were quite a few. So I don't really understand how it all works. I just know that there's some general correspondence between the sun and the El Nino cycle, and some general correspondence between the frequency of El Ninos and global climate.
So if I remember correctly, my dad has told me that when he was a kid in 1936, it was incredibly hot in the summer, and I believe it was cold in the winter. It was a crazy year. Is there any explanation that you might have for why that happened in that year?
Well, the world was starting a cooling period, and climate gets pretty erratic when the world is cooling. So the Little Ice Age was the same way. I mean, they had incredibly cold winters and incredibly hot summers frequently, especially when at the bottom of the Little Ice Age went at the worst time, which was the 1690s. The 1690s were an awful period. And but when the world warms, the climate stabilizes and it gets more consistent. And that's why, right now, we don't really see a lot of extreme weather relative to the extreme weather seen in the past. The cooling period in the 1930s bottomed out in the early 1940s. And then in the late 1940s, it flattened out and really didn't start warming again until the 70s.
And do you think we might be facing some erratic weather now, worse weather now, if we go into a cooling period next upcoming decades?
Yeah, if we do go into a cooling period, I would expect more extreme weather. But I'm a little unclear what's going to happen in the future. I really don't know.
Another question that just came in to me today is, do you have any thoughts on ice caps on other planets changing in sync with our ice caps, like maybe on Mars?
I've read that. Yeah, I think on Mars, it does seem to be synchronized with what's happening here on a very general sense. Yeah, it's interesting, and it gives us the idea that the sun has more influence than it's given credit for.
Any other stuff you'd want to cover here with our extra time?
Maybe this business of firing editors for publishing papers that people don't like.
Let's talk about that.
Yeah. Roy Spencer and Danny Bracewell wrote a paper that is in one of the links at the bottom of the talk. And it's the post I wrote called Suppression of Science. And really their paper was very reasonable, and it was simply arguing against another paper that used a computer model to attempt to show a conclusion. I won't get into much. It has to do with water vapor and the water vapor and its relationship with temperature. Well, Spencer and Bracewell simply went to the observations, and they showed them that the observations didn't match their model, and that the comparison was bad enough that the model was statistically insignificant. And this caused a huge uproar, even though it was a very straightforward critical paper. Model results on one hand, observations on the other. Well, observations win is what Dr. Feynman has always said, but not in climate science. Model results are king, and if observations don't match, it's the observations that are wrong, right? Well, anyhow, the editor got fired for publishing it, or I think he was forced to resign technically. And I thought that was criminal. And then we see farther in the past that Albert Einstein's thesis was rejected at the university where he was trying to get his PhD. So he didn't get his PhD. He went out and he went to work, but he didn't stop his research. He continued his research, and he continued his discussions with Max Planck who published a journal called the Annalen der Physics in Germany. And Max Planck thought Albert Einstein was onto something. And so he published 4 or 5 papers that Einstein wrote that came from his thesis in his journal. He didn't send the papers out for peer review. He read them, he liked them, he discussed them with Einstein, and he said, this makes a lot of sense. You know, it might not be right, might be right, but let's publish them and go. Well, the papers were a big hit. Everybody loved them. Einstein's reputation was made. And finally, his university took one of the papers, used it as a PhD thesis, and gave him his PhD years after he left the university. So that gives you an idea of how bad peer review can be. It can really suppress very good work, innovative work. And that leads me to the second example. Richard Lindzen came up with an idea that cloud cover changes in response to the surface temperature. So as temperatures on the sea surface and the tropics especially go up, clouds clear away, and they allow more radiation to go up, cooling the ocean. And then when the ocean is cooler, you get more clouds. These are high-level clouds. High-level clouds trap heat, so they don't really emit that much heat. They're so cold that they can't really emit much. These are stratospheric clouds. But at night, when radiation's coming up from the sea surface, the clouds absorb and re-radiate the energy from the ocean surface, and they warm the oceans. This was an observation that Lindzen wrote about and described in 2001. And again, the editor was fired for publishing this landmark paper. And it was furiously debated for 10 years, but by 2010 or 2011, the so-called iris effect, that he named it the iris effect, meaning that the clouds move away so that light can get, or energy can get out. And it was pretty well established. It's been modeled. When the iris effect is incorporated in a climate model, the model results move closer to observations than if it's not there, which is some supporting evidence that the iris effect is important. It's also important to note that when you include the iris effect in a model, the effect of CO2 goes down. So now it's accepted. It's in the IPCC reports. And I noticed in AR6, they went on for pages and pages about Lindzen's iris effect. And they never once mentioned Richard Lindzen. They mentioned all the other papers on the iris effect, but they left his out, even though it was his idea originally. He was the first one to write about it. So, there's a huge amount of politics. There's so little science left in climate science. You might as well just call it climate politics.
So, did I just read some writing from you, possibly, that there's some cap on the ocean temperature of 30 degrees centigrade? Does that sound familiar or no?
Yeah, sure, of course.
Yeah.
Yes, there is. That's basic physics. That's an easy one. No one denies that. 30 degrees is the maximum temperature over the oceans. Probably it's actually a little less, more like 28, when you're looking at a large area. Now, in local areas in shallow water, the water temperature can get up to 35 or 36 degrees, like in the Red Sea, for example. But but globally, yeah, 30 degrees is the maximum. And this was well established and calculated by Sud et al. You can look it up. Also, but it was first presented to the public by Newell and Dopplich, both from MIT in 1979. But I don't know why people didn't pay that much attention to it then. But by the time Sud et al. Was written, which is in 1999, I think, Uh, the the physics was very, very well laid out. So it doesn't really matter what happens as long as there's oceans on the Earth. The temperature is not going to be above 30 degrees C, which is what, around 86 degrees. And you look back at the Earth's history, estimates of Earth's surface temperature going back 500 million years, you can see that they've never exceeded 30 degrees either. We hit peaks in the Paleocene, Eocene thermal maximum, or the so-called PET-DIM, of 25 or 26 degrees C. And earlier, it might have exceeded 30 degrees C briefly in the Permian, but that was probably due to some astronomical event, like an asteroid collision or huge volcanism or something. It's very temporary, brief, if it got over 30 degrees. Now, as a caveat, remember, over land, there's no real limit on temperature. You can reach any temperature over land, but the oceans will moderate that. And there have been times in Earth's history when all the land was crammed together into one big continent. And when that happened, there could be large parts of the Earth that were very, very hot, but that's just over land. Oceans are 70% of the Earth, so the average surface temperature is going to be around 30 degrees maximum.
So I just looked it up. James Hansen in Storms of My Grandchildren, he talks about a future Earth where CO2 has ravaged us, and it says surface temperatures are at 100 degrees centigrade, the boiling point of water, with no oceans in sight. So he's worried that the oceans are going to boil away, but that seems unlikely from your perspective.
I don't see any way he could do that. It covers 70% of the Earth. It's a huge volume. 99.99% of the heat on the surface of the Earth is in the oceans. The atmosphere has almost no heat relative to the oceans. The only way you could get temperatures above 30 degrees C would be a planet like Venus, where there are no oceans, and there's very little water vapor on Venus. So, but if you have water, no, you can't get to 100 degrees C. It would be impossible.
I mean, if the oceans did boil away, where would all that water go then? It's all in the atmosphere somehow? Or what was he thinking?
Yeah, the only reason there's no water on Venus is because the electrical field of Venus is so strong that it splits water into hydrogen and oxygen. So if you split it, then it can escape. But it's too dense if you have H2O for it to escape. And the electrical field on Earth is very weak, so water is perfectly safe here.
Okay,
from a physics standpoint. Hansen has some delusions about that, and I was kind of surprised that Stephen Hawking parroted what he said. Stephen Hawking should have known better, because fundamental physics tells you that the oceans boiling away just couldn't happen.
Yeah, I think the UN chief in the last year or so also was worried about boiling oceans, or global boiling. He used that phrase. So.
Yeah, well, he has an excuse. Stephen Hawking didn't.
Do you have any other stories of people being fired journal editors, or just how about state climatologists? Like David Legates got fired, didn't he? Or
forced to resign. I don't remember. Yeah. I don't know Legates very well. There was some stuff there. He was certainly harassed an awful lot. I've heard Willie Soon talk about it, but I don't know the nitty-gritty details. I've hardly ever corresponded with Legates. The articles that were written about my paper, or our paper, by the other editors of the AJES, or the American Journal of Economics and Sociology, are interesting, but they really say some strange things. Cliff Cobb said that Exxon was behind all the denialism, and Exxon was knew all about the dangers of climate change back in the 70s and kept it all a secret, which is total BS. I went through every peer-reviewed paper that the climate scientists at Exxon wrote, and all their private emails and letters that had to come out in discovery and in court cases. And they published everything that they knew. They had a large contingent, not large, I mean, half a dozen or so scientists at Exxon in their New Jersey laboratory who are true climate alarmists. I mean, they really think climate change is dangerous, or they did back in the 70s and 80s. I don't know if they still do. And they participated in the United Nations IPCC reports, every one of them. And that was the atmosphere at Exxon. That was a place I worked. In fact, I worked in the research lab in Houston for a while, and they wanted to have all viewpoints presented, and they were furiously debated in the meetings at Exxon Production Research in Houston. They would discuss climate change, and I worked for them from 1979 to 1985, and and there was a lot of internal debate, but as more facts came, as they did more modeling, there was a shift in opinion from, yeah, climate change might be dangerous, to, wait a minute, there's nothing here. You know, there's no evidence that anything bad is happening. And their early models are similar to the models that you see today. And you project them out, and they're way higher than observations. And I think that was what convinced people that collectively, okay, the people at Exxon, that, you know, we've looked into this, we've studied it to death, and there's nothing there. And that's their position today. It's my position. Any thinking person who's looked at all the data, I think, is going to come to the same conclusion. In the 1970s and 1980s, sure, you could see that maybe there's a problem. But now, with all the data that we've got and all the model results, which haven't really changed since then, you can see there's no match. The observations tell us that the impact of CO2 is very small.
I want to make sure I heard you right, that you were there a little over 40 years ago on the inside of Exxon, and hearing people talk about climate change and seeing a shift from maybe it's going to be a problem to probably not a problem, that type of thing.
Yes.
Yeah.
Yes. Yeah. It was a huge, I mean, you can imagine. I mean, here you are, Exxon, the largest oil company, private oil company anyway, in the world, and CO2, which is emitted from burning fossil fuels, might be a problem. Well, of course they're going to look into it, and they did. As one guy said, we've researched this to death, and we can't find it. And so, really, what Exxon knew in the 1980s is very different from what people say, because it was really in the 1970s and the early 1980s when they thought there might be a problem. By the end of the 1980s, they knew there was no problem, and they still don't see a problem today.
Yeah, I'm curious, from your perspective then, on the inside of Exxon right now, they don't see a problem, but they don't want to say that publicly. They don't want to pound the table, or they don't want to fund climate skeptics. What do you think's going on there? Do they have any reason that they like the climate scam? They want it to continue for some profit motive? Or what do you think's happening?
Well, I don't know what you've read or heard, but as far as I know, the official position at Exxon is that it isn't a problem right now. And they think that research into it should continue, I've read, but I maybe I'm behind or I've missed something, but I think the management at Exxon doesn't believe there's a problem.
Yeah, I thought within the last 10 years that they had a CEO that was kind of bowing towards the climate scam, like, yeah, we believe in it, but we're doing the best we can. I'll look it up. I'll
Yeah,
email it to you.
it's gone both ways.
Yeah.
There was a position maybe 10, 15 years ago that it's ambiguous. We should be careful, but we don't really know. British Petroleum went through the same thing, so did Shell. But I think pretty much all of them have come around now, and I'm talking the last 5 years when I say now, to saying there's nothing to this.
Do you think any of them have gone as far as saying CO2 is our friend and 430 parts per million is better than 280? Anything like that?
No, for the most part, they're pretty silent and just don't address it, except they have fought off shareholder lawsuits about it, and they don't. And in fact, I think Exxon has come up with a new way for shareholders to vote. I still own Exxon stock, by the way, I guess, full disclosure. It's a good investment, but and pays a good dividend. But there's a new way for us to vote now that kind of makes shareholder lawsuits about climate change harder to get through. They were forced by shareholders, again, the billionaires who want a global government, they were forced by some of them to make some changes in their board, but they've gotten the climate skeptics off the board now. So maybe that's some of what you heard, because some of these shareholder lawsuits and shareholder votes managed to get some climate change people on the Exxon board, but I think they've gotten rid of all of them now.
Yeah, I'm just curious. I see some climate skeptic scientists that are kind of starving for funding, and it would be nice if Exxon could give them a little funding, but maybe Exxon doesn't do it because it's politically incorrect still.
Yeah. Why don't they fund organizations like the CO2 Coalition and Clintel? I don't know. But as I'm a member of the CO2 Coalition and Clintel, and then neither one of them get any money from the fossil fuel industry, which just, Clintel won't take it, but I think the CO2 Coalition would, but they just hasn't been offered. The funding at the CO2 Coalition's all private individuals. But I don't. Yeah, I don't get it. I would think that they would, but they don't.
Okay. Any other points you'd like to make before we finish up?
No, I think that's it. I just hope that people stay skeptical. You should always be skeptical of anything you see in the news media, and research it yourself. Try and go to primary sources. Go back to the actual research. And to the other scientists out there, write in plain language, please. This science speak that most of those 29 million peer-reviewed papers out there is written in is very hard to read. Albert Einstein could write clearly. And his papers are wonderful to read, or any of the great 19th century scientists who had a real impact. So if you want to have an impact, write clearly, write in plain English, write for the public, don't write for your peers. That's my last word on this subject. I want people to be able to read it, pick up a scientific journal and read it, with just a high school education. And you can write like that if you really try.
So maybe your clear writing style is part of the reason why the paper was so successful, top 1%.
Yeah.
Very readable. Yeah.
Yeah.
All right. On that note, I will let you go, but thanks a lot for all the work you're doing, Andy May. Appreciate it.
Okay. Thanks, Tom. Bye.